have this practice question. It says a storage tank contains 2 moles of helium, 3 moles of oxygen, 5 moles of nitrogen at a total pressure of 762 millimeter mercury. Calculate the partial pressure of each. So let's solve. It is very simple. Hello and welcome back to today's episode. Our topic today is Dalton's law of partial pressure. Now, Dalton's law states that if there are a mixture of gases which do not react together chemically, then the total pressure exerted by the mixture is the sum of the partial pressures of the individual gases that make up the mixture. Now, what is Dalton trying to say? Dalton is trying to say that if there are gases that mix together, for you to get the total pressure, you have to sum up the individual gases that make up that mixture. So what does that mean? It simply means that P total is equals to PA plus PB plus PC. This is just like if you make your popular tea to drink. In your tea, if you want to get the total quantity of the tea, you have to find out the mass of the water you used. You have to find out the amount of cube of sugar used, the amount of milk used, the amount of tea used. So when you find out the total number of all these quantities, that will make up the total mixture. So that's exactly what Dalton is trying to say. Now, if the gas is collected over water, it simply means that there are some water vapor in that gas. So in that case, it will be P total will be P gas plus P water. So this is basically what Dalton is trying to explain. Now, let's look at the various formulas involved in Dalton's law of partial pressure. Okay, so let's look at the following. Now, these are the various formulas used in solving Dalton's law of partial pressure questions. So let's look at them. The first one is P total is equals to the sum of the individual gases that make up that mixture. Then, if the gas is collected over water, you have that P total will be P gas plus P water. Now, this P water is usually at SVP, that is saturated vapor pressure. We'll still meet the questions. Then you have here PA, that's partial pressure. Here you have that partial pressure of A is equal to mole fraction. Mole fraction. X means mole fraction. So partial pressure of A is equal to mole fraction of A multiplied by total pressure. To get your mole fraction is simply mole fraction of A is equals to number of mole in A divided by the total mole. If you are looking for the mole fraction of B, the mole fraction of B will be number of mole of B divided by the total mole. This can also be gotten by partial pressure of A divided by the total pressure. If it is B, partial pressure of B divided by the total pressure. Then you have here total mole fraction can be gotten by addition of the individual mole fraction that make up that mixture. Please, you need to memorize these formulas. You need to memorize them because once you see questions under Dalton's law of partial pressure, they can ask you any of these. So it is important that you write them down and memorize them. So now let's look at different practice questions. Okay, so let's look at this question. A certain mass of gas collected over water at 9 degrees Celsius and 712 millimeter mercury has a volume of 25 cm cube. Calculate the volume when the pressure is 765 millimeter mercury and temperature is this. SVP of water at 9 degrees Celsius is this. Remember what I told us? If you find a question, 1, collected over water, it should tell you this is Dalton's law. Then at the end, they now told you that SVP of water at this. That should tell you must subtract that there is P gas and P water. So you must subtract in order to get your P gas. So let's solve. Now, our temperature T1 is what? 9 degrees Celsius. You're going to add 273 to it, and that will give us 282 Kelvin. Then you have P1 to be what? 712 millimeter mercury. Now, the question says SVP of water at 9 degrees Celsius. So at 9 degrees Celsius, what's the pressure at 9 degrees Celsius? The pressure at 9 degrees Celsius is what? 712 millimeter mercury. So you are going to subtract this. You are going to subtract this from this, just like you have here. P total is this. P water is this. So to get the P gas, you subtract this from this. Are we together? So 712 minus 17. What do you have? This minus this will give us 5. You give us 9 and 6 millimeter mercury. If you fail to subtract, just know that you have failed the answer. Then you have your, what the next thing? V1. V1 is 25 cm cubed. Then you also have what again? P2, 65 millimeter mercury. And then temperature is what? 16 degrees Celsius. Add 273 to it. This plus this is 9. This plus this is 8. 298 Kelvin. Now we can solve using the general gas equation. So which is what? P1 V1, which is what? P1 V1 all over T1 is equal to P2 V2 all over T2. What's our P1? P1 is 695 times V1 25 all over T1 282 is equal to P2 765 times V2. V2 is what we are looking for because the question says calculate the volume all over T2. T2 is what? 289. All right. So what do? We cross multiply. When we cross multiply, we have that V2 is equal to 695 times 25 times 289 all over 282 times 765. So let's punch our calculator. 695 times 25 times 289, that will give us 5,202,1,375 divided by 282 times 765. That will give us 215,730. So let's divide. We have that 50,213,75 divided by 215,730. So you have it to be 23.276. So let's leave our answer to the nearest whole number. Our volume will be what? 23 cm cubed. Answer. Okay, so we have this practice question. It says a storage tank contains 2 moles of helium, 3 moles of oxygen, 5 moles of nitrogen at a total pressure of 762 millimeter mercury. Calculate the partial pressure of each. So let's solve. It is very simple. Okay, now I want us to look at these formulas here. Now, the one that we're going to use here depends on the parameters that we are given. So let's write out our parameters. We have number of mole for helium is 2. Number of moles for oxygen is 3. Number of moles for nitrogen is 5. We have written the number of moles. What else were we given? We are given P total. P total is 762 millimeter mercury. And we are looking for what? The partial pressure of each of them. So let's look at our formulas again. First of all, we have to find their mole fraction. And in order to get their mole fraction, we have to use this formula to find their mole fraction. So to find the mole fraction of, let's begin with helium. To find the mole fraction of helium, it will be what? N helium divided by N total. So let's find the N total. N total will be sum of the moles. So you have 2 plus 3 plus 5, and that will give us 10 moles. So helium, what is that of helium? Helium is 2. Number of mole of helium is 2. So 2 over 10, that will give us 1 over 5. What about the mole ratio of, what's the next one? Oxygen. The mole ratio of oxygen will be number of mole of oxygen over total. So what would that be? That of oxygen will give us what? 3 over 10. So let's look for the mole ratio of nitrogen. The mole ratio of nitrogen is equal to number of mole of nitrogen divided by what? N total. So what's the number of mole of nitrogen? 5 over 10. And that will give us 5 divided 1 into this 2. That will give us 1 over 2. So these are their mole fraction. Are we together? They are mole fractions. Now we have gotten our mole fraction, but the question says we should find the partial pressure. So to find the partial pressure, what are we going to do? We are going to use this formula to find the partial pressure. So to find the partial pressure of each of them, we are going to use this formula. So to find the partial pressure of each of the gases, let's begin with helium. So to find the partial pressure of helium, it is going to be mole fraction of helium multiplied by P total, just like you have here. That's why you have to memorize these formulas. So what do you have? What is the partial pressure of helium? That's what we are looking for. What's the mole fraction of helium? The mole fraction of helium is what? Helium 1 over 5. 1 over 5. 1 over 5 times P total. P total is given as 762. 762. Then partial pressure of oxygen will be what? Will be mole fraction of oxygen multiplied by P total. So what's the mole fraction of oxygen from the question? 3 over 10. 3 over 10 multiplied by what? Total pressure. Then the last but not the least is that of nitrogen. P partial pressure of nitrogen will be what? Mole fraction of nitrogen multiplied by P total. And the mole fraction of nitrogen is 1 over 2 multiplied by P total. P total is 762. So we can now press our calculator. So you have that 762 times 1 divided by 5. That will give us 152.4 millimeter mercury. Then the second one is what? 3 times 762 divided by 10. That will give us 228.6 millimeter mercury. Then the last but not the least, 762 divided by 2, that will give us 381 millimeter mercury. So these are the partial pressure of each of the gases. Isn't that simple? Let's look at another question. Okay, let's look at another practice question. A mixture of 40 grams of oxygen and 40 grams of hydrogen gas has a total pressure of 0.900 atm. What is the partial pressure of each gas? It is very simple. So let's solve. What do you do here? First of all, let's write out our parameters. We are given our mass in gram of oxygen. Mass in gram of oxygen to be what? 40 grams. And that mass in gram of hydrogen to be what? 40 grams. And then we're given our pressure. So what are we going to do? So we are going to find the number of moles. And to find the number of moles, you will say number of moles is equal to what? Mass in gram over molar mass. Alright, if you have not watched my video on stoichiometry, please do that so that you can understand this, how to find, so that you can understand how to calculate the number of moles. So you have that mass in gram. Let's look at that of oxygen. Mass in gram of oxygen is 40 over molar mass of oxygen is what? But we know that oxygen Oxygen is what? 16. 16 times 2 is what? 32. This is the atomic mass. 16 is the atomic mass of oxygen. You multiply it by 2. That will give you 32. So if you divide it, it will give you 1.25 moles. Then, let's look for the number of mole of hydrogen gas. Mass in gram is 40. Then, molar mass of hydrogen gas will be what? Hydrogen is 1. 1 times 2. That will give us 2. So this will give us 20 moles. So we have been able to find their number of moles. So with this, we can find their mole fraction. And when we find their mole fraction, we multiply it by the P total, just like you have it here. So let's find our mole fraction. So to find our mole fraction, we are going to say mole fraction of oxygen will be what? Number of mole of oxygen divided by total number of moles. So what is the mole? What is the mole of oxygen? The number of moles of oxygen is 1.25 divided by the total. So let's get the total. The total will be 1.25 plus what? 20. And that will give us 21.25 moles. So we are going to divide by 21.25 moles. And that will give us what? Let's press our calculator. 1.25 divided by 21.25. So that will be 0.0588. Then let's look at the mole fraction of hydrogen gas. That will be number of mole of hydrogen gas divided by N total. So number of mole of hydrogen gas is what? 20 divided by N total, which is 21.25. So 20 divided by 21.25, you have it to be 0.9411. 0.9411. So with this, we can find their partial pressure. So to find their partial pressure, it will be what? We are going to use this formula. Partial pressure of oxygen is equals to mole fraction of oxygen multiplied by P total. So what is the mole fraction of oxygen? The mole fraction of oxygen is 0.0588 multiplied by P total. P total from the question is what? 0.900. So then the partial pressure of hydrogen will be what? Mole fraction of hydrogen multiplied by what? P total. What's the mole fraction of hydrogen? From the question here, from here, it is 0.9411 multiplied by P total, which is what? 0.900. So what do you have? Let's multiply. 0.0588 times 0.90. You have this to be 0.05292 millimeter. Okay, sorry. ATM. This is ATM. Then for this one, you have it to be 0.9411 multiplied by 9. So you have this to be 8.4699. So this will be 8.4699 ATM. Answer. Isn't that simple? Now I'll give you a question to solve. Put your answers in the comment section. Okay, so this is question 1 and this is question 2. So I need you to solve them and put your answers in the comment section. Now the question says a certain mass of gas collected over water at 8 degrees Celsius and 706 millimeter mercury has a volume of 18 cm3. Calculate the volume at STP. Okay, I believe we know what to do here. Please don't forget that SVP of water at 8 degrees Celsius is this. So remember to subtract this from this in order to do what? Get your P gas before you solve. Then 2. A tank contains 1 mole of oxygen and 2 moles of hydrogen with a total pressure of 70 millimeter mercury. Find the partial pressure of each gas. So to find the partial pressure of each gas, you are going to first of all do what? Find their mole fraction. So to find their mole fraction, we're going to use the number of mole of each of the gases over the total number of moles. Then after finding the mole fraction, you're going to multiply the mole fraction of each of the gases by the total pressure. I hope that is simple. All right. Thank you for watching. Please do well to subscribe to our channel and also invite your friends to do the same. All right. Thank you. Bye.